talking about tessellations. So tessellations are patterns that can be repeated over and over again, which there are no overlap or any gaps. So we're talking about regular tessellations, which are made by repeating regular polygons. So first we'll talk about what exactly does make something a tessellation. So it has a lot to do with angle measure. So one of the first things I want to point out, let's look at a triangle. So you start by selecting 2 points. A triangle has 3 vertices, so you'll hit OK. So here's your triangle. So now let's go to angle measure right here, and we'll click on the 3 points, and we get the angle measure of 60 for this triangle. Okay, so now let's keep flipping this triangle around so we can make a tessellation. So you can go to rotate around a point. You will click the triangle. I'm going to select A, and since the interior angle of that triangle is 60, I'm going to hit 60 and hit OK. So I'm going to do the same thing over again. Hitting 60. And I'm going to keep doing this until every side is all filled in. Okay, so we will be able to keep repeating this over and over again until the entire page is full. So also what you want to notice is that at every vertex, the pattern is going to be exactly the same. So right here at this vertex, there are 6 other triangles, and the interior angles of all those triangles add up to 360. So now I want to move on to squares. So let me go back to regular polygon. Okay, so I want to do the thing I did before, and we all know that squares have a 90-degree angle on each angle. So let's go to rotate around a point, select your square. I want to select F, and we're going to rotate at 90 degrees because that's the angle at each vertex, the interior angle. So flip it like that. I'm going to do the same thing for E. Well, first I'm going to select this, select E, 90, okay. Select this, E, and 90. Okay, so that's also made a square. So now at the vertice, there is 4 interior angles, and they all each out to 360 again. So if you'll notice, every regular tessellation is going to have an interior angles that add up to 360. So now I want to show you guys the hexagon. There are 6 vertices in a hexagon. So you'll do the same thing as before, rotate around the point. I'm just going to select M, and then for a hexagon, the interior angles are 120, so I'm going to rotate it that much, and I'm going to select it again, select L, and you get the drift. Just keep doing it until everything is all filled in. And like I said before, I'm only doing the first layer, but you can keep going and building off of the other ones. So kind of like if I treated this hexagon right here as a center, like I'm doing for this one right here, I would just keep building off on the side, so it would be over here. And you can keep repeating this just for forever. Okay, so now it's all filled in. And the same, so if you look at this vertex right here, there are 3 angles, interior angles, and they all add up to 360, so you know it works. So now I'll talk about one that doesn't work. So I'm going to draw a pentagon. So there are 5 vertices of the pentagon, and we could do the same thing. So actually, first, let's check the angle measure, because I don't know this off the top of my head, and it's 108. So let's rotate around the point. I'm going to select N, rotate it 100.